Okay, so here's the setup. A bird drops a stick to the ground from a height of 80 feet. Um, and just fun fact, is the stick ever going to go above 80 feet if the bird drops it? No, it's not. So we already know something about its highest point in this whole thing. It's going to be as high as 80 feet, nothing higher. Now, the function that they give us, h, the height, equals negative 16 t squared plus 80. That gives the stick's approximate height, h, above the ground in feet after t seconds. So we're going to graph the function, and then it says about what time does the stick hit the ground. Okay, well, I know, I know just from looking at this, and I'll explain why in a little bit, but I know that because we're never going to go above 80 feet, like I had just said, then I can mark this as this axis as like that's 10, that's 20, that's 30, that's 40, that's 50, that's 60, that's 70, that's 80. And it's never going to be above that. Okay? Now, I also know at the bottom, and I can talk about this later, is we're going to have 1 second, 2 seconds, and I won't need more than 3 seconds for this stick to reach the ground. So that's how it's going to be broke down into a quarter of a second. Okay? Um, Now remember, because the scale is so much different, on the x-axis it takes 4 boxes just to do 1, and on the y-axis 1 box equals 10. So the scale is kind of distorting this graph from if it was just 1 unit per box in both directions. But the shape is going to be the same, or it's going to be, it's going to be um, a very related shape that fits our situation. Otherwise, we would have a massive graph to be able to graph this properly, or some values would be so small you wouldn't see them. So let's make a table. Okay. So we say here's x. Actually, no, not x. T is the time, and h is the height. So I'm going to write over here. I'm going to say negative. I'll do it down here maybe for calculation's sake. Negative 16 t squared plus 80. And if t was 0, we'd get negative 16 times 0 squared plus 80, which is negative 16 times 0, or 0, plus 80. 0 plus 80 is 80. So when t, the time, is 0, the height is 80. And that makes sense because at time equals 0 means the time that the bird dropped it, and as soon as it lets it go, it hasn't fallen yet, and that's right there at 80. Okay? So I plotted that point. Let's do it again. I'm going to get my eraser in there and get out the 0 that I put in. And let's try 0.5. Okay, 0.5. At 0.5, we say 0.5 squared is 0.25. 0.25 times negative 16 is negative 4. And negative 4 plus 80 is 76. So that's 76. And if we plotted that, we'd say half a second in. That's if this whole distance is 4 boxes a second, then half a second gets you right to there. And then how high up is it? Well, negative 1, I'm sorry, 0.5 goes up to, right around there. Okay, let's keep going. Let's put in 1. Let's try 1 now. Get that out of there. Let's try 1. What is 1 when we square it? 1 squared is 1. Negative 16 times 1 is negative 16. Plus 80 is going to be, let's see, 64. So we've got 1 comma 64. And if we plotted that, 1 comma 64, well, here is 1 comma 50, 1 comma 60, 1 comma 64 is right around there. Right? Let's keep going. I'm going to do 1.5. Let's see. Get those marks out of there to calculate it. 1.5, let's see. 1.5 when you square it is 2.25. 2.25 and 2.25. You can write this multiplication out over on the side, but 2.25 times 16 is 36, so negative 36. And what's negative 36 plus 80? It's 44. So over at 1.5, going over here to 1.5, we've got an output of 44. And where is that? It's about there. Okay. And you can see that it's starting to fall more rapidly as we go. Let's do 2. What I mean is when you look at the graph, you can see that it's starting to curve downward. Okay? And it makes sense because when things fall, they speed up as they fall. So plugging in 2 there, 2 squared is 4. Negative 16 times 4 is negative 64. I know that one. And negative 64 plus 80 is 16. So when we have 2 seconds in, we've got this thing is down to 16. And so if we plot that, that's like this, 2, comma, here's 15, here's 16, right around there. Yeah? And this is saying about what time does the stick hit the ground. So this is what I'm going to do. We could continue calculating it, but since it's falling faster and faster and faster, then putting in 2.5 is going to get us way below 0. And it's not going to go below 0. It's going to go to 0, which is where the ground is, and it's going to hit it and stop. Right? So what time is that? Well, I'm going to erase all of our calculations, and I'm just going to make a sketch of this line and kind of follow it naturally to its conclusion. Okay? There's some mathematical ways of finding exactly what the value is. We could just put in 0 for the height, which is, when the height is 0, it's on the ground. It's hit the ground, right? Figure out the t value for that. But I'm going to sketch this. I'm going to say it's going like that. And we see that it looks like it's essentially about, well, let's see. That's 2 1/4, so maybe 2.2 seconds in, 2.15 seconds in. And if we wanted to plug in a number, we could try it. But about what time does it hit the ground? I'm going to say that just a little more than 2 seconds is kind of sounds like a satisfying answer to me. No, actually, I'll go a little further because now that I'm looking at it on the answer page, it does say what I had originally said, which is about 2.2 seconds. So I'm going to say that because it is clearly a little bit more than 2. So about 2.2 seconds. Okay, and how do we know that? Because I broke this number of seconds down into 4, so this is 2.25 seconds right there. So it's 2.2 seconds. And if you wanted to check, you could plug that in. You could plug 2.2 into the equation, and if we wrote that out, I can write it on top, why not? Negative 16 times 2.2 squared plus 80. Okay, and 2.2 squared is, let's see, 4.84. So negative 16 times 4.84 plus 80, and This becomes like negative 77-ish and a half plus 80 means that's a little bit more. It's like at 2.2 seconds, it's that many feet above the ground, 2 feet above the ground, and moving very quickly towards it. So that's about right. That was just a little check that I did there at the end to see if the estimate that we got of 2.2 seconds actually uh, gets us pretty close to zero from our 80. That was our original height, and it does. So there you go. How do you do it?